Hello, welcome to next session. And this session will solve K2113 production and investigation paper. Okay. So the question number one is the fixed cost and the variable cost of production of a product are rupees 20,000 and rupees 50 per unit respectively. The demand for the item is 500 units to break even point. The unit price of the item in rupees should be option A 50, option B 75, option C 90, option D 100. Okay. As the fixed cost is your 20,000 and variable cost is 50 per unit, then demand is a 500 per unit, so 500 units. Okay. So at break-even point there is no profit, no loss. Okay. So the total sale is your uh, unit price. Unit price into break-in quantity and total cost, your fixed cost plus variable cost. Variable cost is P into Q. So equating these two, we can get the unit price. That is 90. Next, sublifts refer to option A, basic type of fixtures used in machining. B, fundamental motion used in manual work. C, basic type of waste in manufacturing process. D, fundamental types of material handling system. This is option B, the fundamental motion used in manual work, service, catapult, hand movement, and various other movements. Okay, so these are the fundamental motion used in manual work. Okay, next, the customer arrive at a ticket counter at a rate of 50 per hour, and tickets are issued in the order of their arrival. The average time taken for issuing a ticket is 1 minute. Assuming that the customer arrival from a poisons process and service times are exponentially distributed, the average waiting time in queue in minute is, so the arrival rate is your 50 per hour and service rate is one ticket per minute or 60 per hour. Okay, and so average waiting time, the formula for average waiting time is just lambda divided by lambda is your arrival and you get services lambda divided by mu mu minus lambda. So putting the value, we can get average time in average waiting time in queue is just 1 by 12 hours or 5 minutes. Okay. Next, circular blanks of 10 mm diameter are punched from an aluminum sheet of 2 meter thickness. 2 mm thickness. Okay, 2 mm thickness. The shear strength of the aluminum is 80 MPa. The minimum punching force required in kilonewton. Option A 2.5 2.57. Option B 3.29. Option C 5.03 and option D 6.32. Okay, so here the diameter of the blank is 10 mm and thickness of sheet is just 2 mm. Okay, and shear stress is just 80 MPa. Okay, for carrying out the shearing, uh, the area which is responsible for shearing is 580. Okay, so this multiplying this shear strength with area. Okay, so area here 580. So 5 into 10 into 2, so that is 62.8, and area is 62.8, and your tau is 80 MPa. So answer is 5.0, oh sorry, 5024 Newton or 5.024 kilonewton. Okay, so this just you have to multiply this maximum shear stress with the area and you can get minimum punching force. Okay. Next, a metric thread of pitch 2 mm and thread angle 60 dB is inspected for its pitch diameter using three-wire method. The diameter of the best size wire in mm is option A 0.866, option B 1, option C 1.154, and option D 2. The best size wire diameter is the diameter when the wire touches the pitch line. Okay, so this is your wire and this is your pitch line, and it touches the pitch line. Okay, this is your pitch line. So it touches the pitch line and it is perpendicular to the surface. Okay, so this is the best side of the wire, and here the third angle is your 60 degree. So this angle is 60 degree and theta by 2 is 30 degree. Okay, and theta by 2, and this will be also theta by 2. Okay, now uh, we have pitch as 2 mm, and so the pitch is the distance between the corresponding point on the threads. Okay, so this will be your this will be your so uh, if it is your p by 2, so then this will be a p by 4. Okay, because this is the one here it is p by 2, so p by 4 and it is p by 4, and these are not corresponding, and corresponding point will be next thread and this. Okay, so this will be p by 4, and p is your uh, P is your 2 mm. Okay, so this is your 2 by 4. Okay, and this angle is known. That angle is your 30 degree. So we can find out R. Okay, so CA divided by cos theta by 2 is equal to R. Okay, R will be your P by 4. So CA is your P by 4. So P by 4 cos theta by 2. So putting the values, we can get the diameter. Okay, so answer is your 1.154 mm. Okay, here theta is your 60 degree and P is your 3. Okay, next, match the correct pairs process characteristics application. The processes are friction welding, gas metal arc welding, R tungsten inert gas welding, S electroslag welding. So, and the characteristics are non-consumable electrode, joining of thick plates, C consumable electrode wire, for joining of cylindrical dissimilar materials. Option A P4Q3 R1 S2. Option B P4Q2 R3 S1. Option C is P2Q3 R4 S1. Option D P2Q4 R1 S3. Okay. Uh, the right answer is A, because friction welding is used in joining of cylindrical dissimilar materials. Okay, and gas metal arc welding is used uses that is big. Okay, big uses consumable electrode. Okay, and TIG uses non-consumable electrode. Okay, or electrostatic welding uses used in joining of thick plates. Next, in a rolling process, the state of stress of material undergoing deformation is subjected to uh, pure compression, pure shear, compression shear, tension shear, transfer shear, compression and shear. Okay. Consider one-dimensional steady state heat conduction along x-axis, bracket 0, x is very much 0 to L, okay, and through a plane wall with the boundary surfaces x is equal to 0 and x is equal to L, it maintained at temperature of 0 degree Celsius and 100 degree Celsius. Heat is generated uniformly throughout the wall. Okay. X is 0 and uh, two surfaces are maintained at 0 and 100 degree. Okay. So heat is being generated through the wall, and to the correct statement. Option A, the direction of heat transfer will be from the surface at 100 degrees Celsius to the surface at 0 degrees Celsius. B, the maximum temperature inside the wall must be greater than 100 degrees Celsius. The temperature distribution is linear within the wall, and temperature distribution is symmetric about the midplane of the wall. So answer is B. Wow, why? Because the maximum temperature that is maximum temperature inside the wall must be greater than 100 degrees Celsius because there is uniform heat is generated. Okay, and heat will transfer from the source to the two walls. Okay, so the maximum temperature will exist within the wall. So and at the wall the temperature is 100 degrees Celsius and 0 degrees Celsius. So the maximum temperature will be more than this 100 degrees Celsius or 0 degrees Celsius. Okay. So first point is as the uniform heat is generated, heat transfer will take place from a point of maximum temperature within the surface to the outside surface. So the maximum temperature inside the wall must be greater than the outer surface. Okay. Next, sorry. So this B is correct. Okay. Now the checking other options. The temperature distribution may not be linear in if the thermal conductivity because it is not given that thermal conductivity is constant. Or if it is varying with temperature, then the temperature distribution will not be linear. Okay, and this is valid for only constant thermal conductivity. Okay, and temperature distribution may not be symmetric about the midplane. Okay, may not be symmetric about the midplane because these two spaces are having different temperature. Okay, so maximum temperature will not exist at the midplane. Okay, so as the temperature is also different, so it is not true. Okay, so heat will transfer from the uniform heat source generation to one. Okay, so direction of heat will not be from 0 degrees 100 Celsius to 0 degrees Celsius. It will be from the point where the maximum temperature exists to these wall. Okay, so answer is B. Next, a cylinder contains 5 meter cube of an ideal gas at a pressure of 1 bar. The gas is compressed in a reverse isothermal process till the pressure increases to 5 bar. The work in kilojoule required for this process is initial volume is your 5 meter cube and initial pressure is your 1 bar. Okay, the final pressure is your 5 bar. Okay, and isothermal process has been performed. Okay, so P1 given is equal to for analyzing gas uh, P1 given will be equal to P2 V2 for constant temperature process. Okay, so from this we can as initial volume and initial pressure and final pressure are known. Okay, so we can calculate final volume. Okay, so the work done by the gas is your nothing but PdV integration and V is varying from V2 to V1 or V1 to V2. So putting this value, you can get the value that will be 804. Okay, P1 or by putting P is equal to P1 V1 by V. Okay, so it will be P1 V1 L1 into V by V1. Okay, so it will be 804.718 kilojoule. Okay, so what required will be so answer is your A. Okay, next, a planar closed kinematic chain is formed with rigid link PQ 2 meter, QR 3 meter, RS 2.5 meter, SP 2.7 meter with all revolute joints. The link to be fixed to obtain a double rocker or rocker mechanism is so for rocker mechanism the link opposite to the shortest link is fixed. Here the shortest link is your PQ and so if we draw the kinematic then we will exact PQRS and so the link opposite to shortest link is your SR. Okay, so for the local mechanism, SR should be fixed. So SR is or RS is the answer. So answer is your C. Next, let X be a normal random variable with mean 1 and variance 4. The probability X less than 0 is option A 0.5, option B greater than 0 and less than 0.5, C greater than 0.5 and less than 1.0, D 0. Okay. In normal distribution, the variation of probability is shown by this figure. Okay. It is zero point 0.5 on either side of the mean. Okay. Uh, so the probability will be zero point 0.5 from 0 to from 1 to minus infinity in this direction and will be 1 to plus infinity in this direction. Okay. So whenever it is asked, so here it is asked that probability x less than 0. So x 0 will exist somewhere here. Okay, somewhere here. Okay. So and here mean is your one. Okay, so from this to this the probability is zero point 0.5. Okay, from 0 to minus 50 it will be less than zero point 0.5, but it will have some value. Okay, so answer is your B. Next, choose the correct set of functions which are linearly dependent. A sin x, sin square x, and cos square x. B cos x, sin x, and tangent x. C cos 2x, sin square x, and cos square x. D cos x, sin square x, and cos x. So we know that sin square x is equal to 1 minus cos square x, and cos 2x is equal to cos square minus x minus 1, cos square x minus 1, and cos 2x is equal to 1 minus two sides correct. Okay. Now, now we have three, uh, three terms. Okay, sin square x, cos 2x. Okay, and cos square x. Okay. Now sin square x is can be written as sin square x. Okay, and cos 2x can be 1 minus 2 sin square x, and cos square x is 1 minus sin square x. So all other terms can be written in the form of sin square x. So these are the linear independent functions. So if we take sin square x as z, then the first term will be z. This is 1 minus z. This will be 1 minus 2z. Okay, this will be 1 minus 2z. Okay. So this will be a linear relationship. Okay. Next, the eigenvalue of a symmetric matrix are all option A complex with non-zero positive imaginary part, B complex with non-zero positive imaginary part, B real and pure imaginary. Okay. What is symmetric matrix? Symmetric matrix is one where the A is equal to A transpose. Here, so let us take a symmetric matrix two, which is AB, BA, and its transpose is equal to this matrix. Okay. Now find out this eigenvalue. Okay. So eigenvalue can be converted A minus lambda, B A minus lambda. Where lambda is here, eigenvalue. Solving this matrix, we get lambda is equal to a minus lambda is equal to plus minus b, or a minus lambda here is equal to b square. Okay. So lambda is your lambda can be either a minus b, okay, or it can be a plus b. Okay. So which are real, not the imaginary. Okay, because here b square is there, not minus b square is there. Okay. So these are real. Okay. So answer is your next. The partial differential equation curly u by curly t and curly u by curly t plus u curly u by curly x is equal to curly u square u by curly x square is option A linear equation of order 2, B non-linear equation of order 1, C linear equation of order 1, D non-linear equation of order 2. Okay. So the order of the partial differential equation is determined by the degree of the by the highest derivative present in it. Okay, so here the order is your 2. Okay, and linearity is checked by this equation is not linear because here it is the multiplication of u and curly u by curly x. So this does not the relationship for linear equation. So this is not linear. So the order is 2 and it is non-linear equation. Okay, so order is 2 and it is non-linear equation. So answer is your next. Match the correct pairs. So numerical integration scheme and order of filling polynomial. So these schemes are Simpson's 3 by 8 rule, Familial rule, Simpson's one third rule, order of fitting polynomial first, second, and third. Okay, so that we have to cramp or remember. Okay, so answer will be P3. So P3 is the third order of fitting polynomial, and Simpson rule is the second, and Familial rule is the okay. This question has been asked in previous papers also. The Simpsons one by third rule is parabola or okay, so it is second order. Okay. Next, a road of length L having uniform cross-sectional area A is subjected to a tensile force T as shown in the figure below. If the Young's modulus of material varies linearly from E1 to E2 along the length of the road, the normal stress bond at the section is this. Okay. This is your P, force P, this P, and here E1 modulus is T, and E2 is here modulus of length is L, and this section is L by 2 from this end. Okay. So option P by A, B P E1 minus E2 divided by A E1 plus E2, C P E2 divided by A E1, D P E1 divided by A E2. So the order, so here the stress is only the function of the internal resistance per area. It doesn't depend upon E1, E2, etc. Okay, or Young's modulus velocity, you can say. So answer is P by A. Okay. Next, for a steady fully developed inside a straight pipe of diameter D, neglecting gravity effect, the pressure drop over a length L and wall shear stress are related by option A tau W is equal to del P D by 4L, B tau W is equal to del P D square by 4L square, C tau W is equal to del P D by 2L, D tau W is equal to 4 del P L by D. Okay, so this is your pipe for at section 1 the pressure is P1 and at section 2 pressure P2 and in between uh, length L there is length L and tau W is the shear stress, D is the diameter. Okay. Now the area for pressure P1 and P2 is same. This is for this case. Okay. So the force exerted will be either whichever is the most. Okay. So for P1 is more, so force will be this is the thing, and this force will be restricted by the shear stress, shear force. Okay. So P1 over 4D square minus P2 over 4D square is equal to shear stress area pi dl, now W pi dl. Okay. So tau is your from this you can find out tau here del P D by 4L. So answer A is the correct option. Next, for a ductile material, toughness is a measure of option A resistance to scratching, B ability to absorb energy up to fracture, C ability to absorb energy till elastic limit, D resistance to energy. Toughness is the option answer is a B. Toughness is the ability of metal to absorb energy up to fracture, whereas resilience is the ability of metal to absorb energy up to elastic limit. Okay. So hardness is resistant to scratching and indentation. Okay. So your answer should be toughness is measure of ability to exert energy to practice. Okay. Next, a cube shaped casting solidifies in 5 minutes. The solidification time in minute for a cube of the same material which has 8 times heavier than the original casting will be. Okay. Let A be the size of the cube. Okay. Then the volume of cube is A cube and surface area of cube is 6 A. Okay. Now we know that the solidification time is directly related to B by A. Okay. Here, so B is your A cube and A is your 6A square. Okay. So this is from this P that we going to A square by 6. Okay. Now the mass of the now 8 time heavier cube is taken. Okay. It is of same material and it is a cube, so shape is same. Okay, so V1 is equal to, so as metal is same and mass is same, so volume will also be same. Okay, so volume will sorry, density will also be same. Okay, so the mass, sorry, as material is same and so density will be same. As volume is 8 times, as mass is 8 times of the previous mass, so volume will also be 8 times of previous volume. Okay. So now the volume, previously the volume was a cube, now the volume is your 8a cube. Okay, and side of the cube will be then 2a. Okay, and surface area of the cube will be 6 into side here. Okay, side is your 2a. Okay, so now the new time in the similar manner we have changed here. A is your 2a now. T1 will be your 2a square by 6. Okay, so T by T1 is equal to, so from this T by T1 is equal to ratio of these two. Okay, first one second will be 1 by 2 square. So as T1 is your 5 minutes, so T1 will T, so T is your 5 minutes given. Okay, and T1 will be your 20 minutes. Okay, in the first statement it will be the cube shape casting for representing 5 minutes. So T is your 5 minutes. So T1 is your 20 minutes. So answer is your B. Next, a steel bar 200 mm diameter is turned at a speed of 0.25 mm per revolution with a depth of cut of 4 mm. The rotational speed of the workpiece in 160 rpm. The metal removal rate in mm cube per second is, so here the diameter is your 200 mm and feed is your 0.25 mm per revolution. Depth of cut is 4 mm. Rotational speed is 160 rpm. So feed in mm per minute can be found out by multiplying feed by multiplying feed in mm per revolution to rpm. So the feed per minute is your this. This is 40 mm per minute. Okay, and the feed per second is 40 by 60. Okay, so the metal removal rate is your pi dt into feet per second. Okay, so as turning operation has been performed, the metal removal rate will be pi dt into feet per second. So we have all the dimensions that pi d is here 200, t is here 4, so it's here 40 by 60. So answer is here 1675.5 mm cube per second. Metal removal rate is 1675.5 mm cube per second. Okay. Next, in a 3 to 1 principle of fixture design, 3 refers to number of option A clamp required, option B location locators on the primary datum face, C degree of freedom of the workpiece, and operation carried out on the primary database. So 3 is the number of locators on the primary database. Actually, these are the pins. Okay, on the primary, on the first page, there are 3 number of pins, and in the second page, there are 2 number of pins, and in the third page, it is only 1 pin. Okay, these values are perpendicular to each other. So answer is the three. So in our primary datum phase, the number of locators are 3. Okay. Next, in a simple exponential smoothing forecasting, to give higher weightage to recent information, the smoothing exponent, the smoothing constant must be close to option A -1, B 0, C 0.5, and D 1. We know that in a uh, smoothing exponent, simple exponent smoothing forecasting method, the forecast for the next period is given by this Fn plus 1 equal to Fn plus alpha Dn minus Fn. where FN1 is the forecast for next period and FN is the forecast for the present period and BN is the demand of the present period and FN is alpha is the so if we put alpha is equal to 1, then this FN will consider out. So next year's forecast will be equal to demand. Okay, so the sloping or exponent will be equal to 1 4. So equal to 1, so answer is it. Okay. Next, a company manufacture a company manufactures 1,000 toys every day. On an average, 10% of toys are defective, and 40% of the defective toys can be reversed into defect-free ones. The average number of defect-free toys manufactured daily is option A 900, option B 920, option C 940, and option D 950. Okay. As 1,000 toys has been manufactured every day, okay, and only 10% of defective the number of defective toys are your 100, okay, and these defective toys can be reworked, okay, and only 40% of the that can be reworked. So the number of defective toys which is 100, okay, and number of reworked toys are this 100 into 0.4 so that is 40, okay. So the no, so we get 40 correct twice. Okay. So, so average number of twice can be reversed into 3. Okay. So average number of twice we can get is here 100 thousand are manufactured and 100 are defective and 40 are reversed. Okay. So uh, first of all we will lose 100 twice and then we get 40 twice. So the total number of uh, defect-free toys are 960. So answer is 960. Next, the type of chart used to monitor the amount of dispersion in the sample is so amount of dispersion means amount of defects. Okay, so C chart is used for that. Okay, answer is yes. Next, which one of the following mode is the modeled based on adoption capabilities on biological system? So, biological system is related to genetic or algorithm. So, answer is D. Okay. So, next, a company plans to purchase a machine whose uptime needs to be at least 90%, 95%. Okay. They have shortlisted two models of machine with the following characteristics. Machine, Model N, MTBF mean time between failures, hour 60, 40. Okay. Mean time to repair, MKTR, hour 42. Okay. The company should option A only Model M should buy only Model M, B only Model N, C either Model M or N, neither Model M or nor N. Okay, so this is your uh, machine mean time between periods and this is your mean time to repair. So the total time is just 64. Okay, this is total time and total time for the N is just 50. Okay, so the total cycle time for the Model M is 64 and uptime is your 60. So percentage uptime is your 60 by 64. Okay, so that is that comes out 93.75. So it should not be purchased because the company's requirement is to find out to purchase a machine that is having at least 95% uptime. Okay, so this is rejected. Okay, if you take second, the total time is 50 and uptime is 48. Okay, so percentage uptime is 19 for this machine to be purchased. So only N model for answer should be purchased. Next, A manufacturer produces bar designed to be of 100 diameter with a tolerance of point plus minus zero point 0.1 mm. Historical data indicates that the manufactured bars have an average diameter of 9.98 mm with a standard deviation of point have a standard deviation of 0.15 mm. The process capability index is option A 0.08, option B 0.12, option C 0.18, option D 0.27. Okay. So uh, here the deviation is your 0.15. Okay, deviation. Sorry, tolerance is your upper control limit. Here this is the average. Okay, this is standard deviation. So upper control limit is your 9.98 plus 0.15. So that is upper control limit, and lower control limit is at 9.98 minus. Sorry, average diameter is this. Okay, so and the tolerance is this. Okay, sorry. Initially, sorry. This is the diameter is at 10 mm. Okay, that is according to historical data. So according to new data, diameter is your 10 mm and tolerance is your zero point 0.1 mm. Okay, so this is your upper control limit is your 10.1 and lower control limit is your 9.9. Okay, and historical according to historical data, the average is 9.9 and standard deviation is 0.15. Okay, so if we compare our recent process with the historical data, we have to check the upper process control limit and lower process control limit. Okay, so here UCL is your 10.1 and average is 9.98 and sigma is your 0.15. So CPU comes out as 0.2667 and lower capability index is average minus LCL by basically LCL is 9.9 and mu is your 9.98. Okay, so from this we get 0.18. Okay, so the process capability we have to determine the process capability index. So this is the minimum of these two. So minimum of these two is your 0.18. So answer is your C. Next, let P denotes the linear programming formulation of a transportation problem with M sources and N destinations. The dual linear program P has option A M into N variable and M into N constraint, B M into N variable and M plus N constraint, C M plus N variable and N plus N constraint, D M plus N variable M into N constraint. Okay. Suppose here the M is number of sources and N is number of destinations. Okay, and Xij is the size of the shipment from where we consider this transit. Okay, from where house I to destination is. In the transportation, there is one destination and one source, or we can say it is warehouse. Okay, so I is varying from 1 to m. Okay, there are m number of the and j is varying from 1 to m. Okay, okay. Now the consider source I. Total outgoing shipment from this source is here. Uh, from the source, the possible destination are here I1 from the first source. So from the first source, or you can say ith source, the possible warehouses possible delivery will be to 1 to 3 to n number of destinations. So x1, so there will be xi 1 plus xi 2 or xi up to xin. Okay, so this will be the number of deliveries to the to the destination. Okay, so if the outgoing shipment cost cannot exceed AI, okay, then this will be the limit. This is the cost of the uh, this is the cost of the delivery from the source I to the source 1, 2, or to n. Okay, and so as I is varying from 1 to n, so I is varying from 1 to n. Okay, so this is I is varying from 1 to n. So this will be your okay. This will be your equation. Okay, first constraint. Okay, now consider J. J that similarly J is your uh, destination. Okay, and so the outlier, the rest from the destination, sorry, from the source to destination to J, so to destination will be there will be equation that x1 J, x2 J, x3 J, and here m are the numbers. So this is different, and I is varying from here 1 to m, okay, and J is your 1 to 3. Okay, so there are this just that m plus n functional constraint. So this is one first constraint. This is second constraint. Okay, there are n constraint here, m constraint here. Okay, so number of constraints will be these are sorry. Okay, so here is m plus n constraint. So answer is B. Okay, next. We stop here and we'll solve the remaining question in the next video.